This is Chapter 5, Strategic Planning, Strategic Capacity Planning for Products and Services. So capacity planning. So capacity is the upper limit or ceiling on the load that an operating unit can handle. So capacity includes equipment, space, and employee skills. So the goal is to achieve a match between long-term supply capabilities of an organization and the predicted level of long-term demand. So if you have overcapacity, the operating costs are too high. If you have undercapacity, you have strained resources and possible loss of customers. So here's some questions. What kind of capacity is needed? How much is needed to match demand? And when is it needed? So here's some related questions. How much will it cost? What are the potential benefits and risks? Are there sustainability issues? And should capacity be changed all at once or through several smaller changes? And can the supply chain handle the necessary changes? So capacity decisions are strategic. So here's some capacity decisions. The impact of the ability to meet future demands. They affect operating cost. They are a major determinant of initial cost. They involve long-term commitment of resources. They can affect competitiveness. They affect the ease of management. And they have an important and complex. They are important and complex due to globalization. And they need to be planned for in advance due to their consumption of financial and other resources. So defining and measuring capacity. Measuring capacity in units that do not require updating. So if you measure capacity in dollars as inflation happens, then you're measuring two different things. So there's two useful definitions of capacity. One is the design capacity, and this is the maximum output rate or service capacity an operation, process, or facility is designed for. And then there's the effective capacity. This is the design capacity minus allowances such as personal time and maintenance. So here's the actual output is the rate of output actually achieved, and it cannot exceed the effective capacity. So the efficiency is the actual output divided by the effective capacity. And then the utilization is the actual output divided by design capacity. So these are measured as percentages. So here's an example. So you have a design capacity of 50 trucks per day, an effective capacity of 40 trucks per day, and your actual output is 30 trucks per day. So your efficiency is actual divided by effective, or 36 divided by 40 is 90%. Your utilization is actual divided by design, which is 36 divided by 50, which is 72%. So here's some of the determinants for effective capacity. Facilities, product and service factors, process factors, human factors, policy factors, operational factors, supply chain factors, and external factors. Or strategy formulation. So strategies are based on the assumptions and predictions about long-term demand patterns, technological change, and competitor behavior. So here's some capacity strategies. So one strategy is leading. So this is where you build capacity in anticipation of future demand increases. The second is following. So you don't build the capacity, or you build the capacity when the demand exceeds current capacity. And then the third is tracking. It's similar to the following strategy, but it adds capacity in relatively small increments to keep pace with demand. So then there's something called a capacity cushion. This is extra capacity used to offset demand uncertainty. So capacity cushion is 100% minus utilization. So here's some capacity cushion strategies. So organizations that have greater demand uncertainty typically have greater capacity cushions. And organizations that have standard products and services generally have smaller capacity cushions. So forecasting capacity requirements. So long-term considerations relative to the overall level of capacity requirements. So they require forecasting demand over a time horizon and converting those needs into capacity requirements. So this is where we go back to chapter 3, forecasting. You're going to spend a lot of money on this capacity, so you want a good forecast. And then short-term considerations relate to probable variations in capacity requirements. So short-term, you're less concerned about cycles and trends than with seasonal variations or other variations from average. Service capacity planning. So there's several challenges related to service capacity planning. One is the need to be near customers, which is convenience. The inability to store services, so you can't store services for consumption later. And then the high degree of demand volatility, so the timing and volume of the demand and the time required to service individual customers. So here's some demand management strategies. So you can offset capacity limitations with supply and demand. So you can have pricing. So if you have a shortage, you could increase your prices. Promotions, you could, if you have excess supply, you could have a promotion, or you could have a discount if you have excess supply. And then there's other tactics to shift demand from peak periods into slow periods. So one of my other favorite restaurants is Red Robin. And so they give you a Red Robin royalty card. So to have a royalty card, you have to give them your email address. And they'll send me emails where they'll all of a sudden say, if you come tonight, you can get 10% off, or if you come tonight or tomorrow night. And so what they're doing is they can send that to any number of customers that they want by doing the email. So I talked to one of the servers, and she said that from her perspective, it was really random who got those emails. I'm sure from a corporate perspective, they're like, well, we predict our demand is going to be short 10% this coming Tuesday. So how many emails do we need to send out to increase that demand? And they can manage that through those emails. So that's an example of a demand management strategy. In-house or outsource. So once you determine capacity requirements, you decide whether you're going to produce the good or service yourself or outsource it. So some factors to consider are available capacity, expertise, quality considerations, the nature of demand, the costs, and the risks. So a bottleneck. So we'll talk about this quite a bit, but a bottleneck is any sequence in the operation whose capacity is lower than the other operations. So here you have operation 1, you get 10 per hour, operation 2, 10 per hour, operation 3, 10 per hour, operation 4, 10 per hour, and suddenly you have to go through this bottleneck operation where you can only do 30 per an hour, but you see that you're putting in 40 per hour. So then what's the optimum operating level? So the optimum operating level, if you look at your average cost per unit and the rate of output, when that, if you're making one of them, it's really expensive per unit as it gets down to the certain point where you have this optimal output rate. And then if you try to do more, you may be paying overtime, you may, other things could cost, so that the cost could actually go up. So you get to the certain point where the cost per unit actually starts going up the more you have. So there's economies of scale and diseconomies of scale. So you have economies of scale if the output rate is less than the optimal level. So increasing the output rate results in decreasing average unit cost. And then the diseconomies of scale, this is where the output rate is more than the optimal level. And this is where if you increase the rate, you have increased average unit cost. So economies of scale. So the reasons for economies of scale is fixed costs are spread over a larger number of units, construction costs increase at decreasing rate as facility size increases, and processing costs decrease due to standardization. Then diseconomies of scale. So the reason for the diseconomies of scale is distribution costs increase due to traffic congestion, or shipping from a centralized facility rather than multiple smaller facilities. Complexity can increase cost. Inflexibility can be an issue, or additional levels of bureaucracy. All of those could cause diseconomies of scale. So facility size and optimal operating level. So you could have a small plant, and you see your average cost per unit is high. You have a medium plant where it's a little bit lower, and a large plant where it's even lower. But it really depends on your output rate. So you see if there's a point where the cost over small and medium overlap. Let's see if I can show it right in here, this overlap region. That, so right here, it's cheaper to have, if your output is here, it's cheaper to have a small plant. Over here, it's cheaper to have a medium plant. And then you come over here, there's a medium plant versus a large plant. And so there's the crossover point. So constraint management. So a constraint is something that limits the performance or process of a system in achieving its goals. So there's different categories of constraints. There's market constraints, resource constraints, material constraints, financial constraints, knowledge or competency constraints, or policy constraints. So this is how you resolve constraint issues. You identify the most pressing constraint. You change the operation to achieve maximum benefit given the constraint. Make sure other portions of the process are supportive of the constraint. Explore and evaluate ways to overcome the constraint. And you repeat the process until constraint levels are at acceptable levels. Evaluating alternatives. So there's some techniques for evaluating alternatives. There's a cost volume analysis, financial analysis, decision theory, waiting line analysis, and simulation. Cost volume analysis focuses on the relationship between cost, revenue, and the volume of output. So you have fixed costs, which tend to remain constant regardless of volume, variable costs, which vary directly with volume. Your variable cost is the quantity times the variable cost per unit. And then total cost is total cost equals fixed cost plus variable cost. Total revenue is revenue per unit times the quantity. Break-even point. Break-even point is where the volume of output at which the total cost and the total revenue are equal. So the total revenue minus total cost equals the revenue times the quantity minus the fixed cost plus V plus Q times Q. So here's the formula. So another way of looking at the break-even point from a retail perspective is Black Friday, where you go through the first half of the year with a loss, and then from Black Friday on, you're making a profit. So that's sort of in a time perspective. This is where you produce the 15th unit. If you can sell 16 units, you're making a profit. If you sell 14, you're at a loss. So the break-even point is 15. So here's some cost-volume relationships. So here on the left, this top one right here. Here you have fixed cost, variable cost, and total cost. So here you have a volume of units, and then the second is here's your total revenue. So here's your line with total revenue, and so now you plot those two on top of each other, where you have the total revenue here and your total cost here. And right here where these two lines overlap is your break-even point, the number of units. So if you sell less than this, or you produce less than this, you're at a loss. If you do more than this, you're at a profit. So then here is profit versus loss. So you say, well, I can the amount of dollars you can have this break-even point, you show the profit and loss, and now you can compare two alternatives. So here's the profit from alternative A and the profit from alternative B, and you have the same break-even point, but in this point here, if there's upsides and downsides with this. So here you have the same break-even point, but you don't. If you're lower than this, you have less loss but less profit over here. So that's sort of a cost-volume relationship chart. So now you can talk about the number of machines, where you vary with if you have one machine, two machines, three machines, and the costs are fixed, and then you can say, well, here's the quantity. So over here, here's the total cost, here's the total revenue. So right here, if I say right here, I have a break-even point if I have two machines, and this is the quantity, and here's the break-even point if I have three machines. So this would be good. It's almost like, well, you might as well start with two machines because don't even have a break-even point with one machine. And then if you can get to this quantity, and then as you come up here, you could then add a third machine as soon as you've hit the capacity. So there's an implication where you have multiple break-even points. So this is chapter 5, and it's been about capacity analysis. So there's a couple of things I wanted to go over the homework now. So the first thing is hierarchical planning. We talked about this before: mission, goals, organizational strategies, functional strategies, and tactics. So the question is, how would you apply this process to your own life mission, goals, strategies, and tactics? So a lot of times we don't even think about having a personal mission statement. You are taking this class to get an MBA. There's a reason. This for some reason you have a goal and a strategy to have an MBA. Does that support your life mission? What is your life mission? Do you have it written down? So as an exercise, I'd like you to write your own mission statement. So write a personal mission statement and post it on the discussion forum. So and it can be as short or as long as you want. So here is my personal mission statement, and it's a really long one. I don't expect you to have this long a mission statement unless you've gone through this exercise before. It has my different roles in there. It's just there for your reference. But what is your mission statement? So that's the forum discussion. These tend to be very personal, so don't comment on others. Just go ahead and take a look at them, share your own, and go from there. And then our assignment. So assignment for next week. This is a written assignment you'll turn in. So consider an assembly line such as a burrito assembly line at Chipotle Mexican Grill. During slow times of the day, one server can handle assembly, but during very busy times, having many servers would be prudent. Explain why either approach wouldn't work all the time and the benefit of matching the number of servers to the pace of customer arrivals. And then the next two questions: who needs to be involved in process selection, and who needs to be involved in layout design? So this is the end of session 2 lectures, and now you have everything you need to do your homework.